Right, so we're going to cover what a logarithm is and how we apply it to our mathematics today. So the definition of the logarithm. So the idea of logarithms is to reverse the operation of exponentiation. So that is raising a number to a power. So for example, the third power or cube of 2 is 8, because 8 is the product of 3 factors of 2. So 2 to the power of 3 is 2 times 2 times 2. Okay, you all should know that's equal to 8. Okay, so it follows that the logarithm of 8 with respect to base 2 is 3. Okay, so log, that's the base of 8 is 3. Okay, so that's the idea of the logarithm. So really, what it tells you is the power, okay, for this base to have that answer. So 2 to the power of 3 gives 8. The log base 2 of the answer 8 is equal to 3. Okay, so what a logarithm allows us to do is to change the subject of exponential equation, such as something like 4 to the power of x equals 7, and we'll look at that a bit later on. So, the rule you need to know, so if y equals a to some power of x, okay, then that power, x, is equal to the log, short for logarithm. Okay, so this is the base number raised to a power, so this is the base of the log of the answer, y. Okay, so that's what you need to know, where the numbers and letters go. So, one way to remember it, so if you go a to the power of x is equal to y, write this back to front. Okay, write this back to front as well. So log base a to the y is equal to x. Okay, and you've got to remember where these arrows go. Okay, so that goes straight down, and that one goes opposite, there and there. Alright, so 2 to the power of 3 is equal to 8. So the log base 2 of 8 means the power of 2 needs to be 3 for that to be 8. So? Yeah, we'll look at that when we come up to it. But yes, in certain situations. Okay, so there's a couple of buttons on your calculator. Alright, there's one that says log, and there's another one that says ln. Okay, on your calculators, so if you've got them, you can get them out and have a look. They're next to each other, I think towards the right hand side. Okay, so 2 buttons on the calculator for log and ln, which is called the natural log. Alright, so when you say the... Okay? Yep.
ln is natural log.
Yep. Alright, so this is log base 10. Pardon me. So, log base 10 is that log button. Okay, and the one you're commonly going to use is the natural log, because it is log of the base e that we've covered in the previous couple of lessons. Alright, so that'll be the one you'll be using more of. That's also a common notation in textbooks, I'm pretty sure you'll see it. Okay, so when you see that, it means log to the base e. Alright, so we covered the value for e a couple of lessons ago. So that's what you need to know. Okay, another feature you need to know. So in the previous couple of lessons we've looked at the graph of an exponential. Okay, so sum y equals a to the x. Might have actually made e's. Alright, so y equals a to the power of x. We had some curve go out of that. Okay, where the intercept is 1 on the y-axis. Your log graph. Okay, so if you were to complete a table of values and plot the point, it'll be something like this. So your exponential never crosses the x-axis. Your logarithm graph will never cross the y-axis. Okay. Now, it's really a reflection. So that's y equals log a of x, base a of x. Put that curve there. That's the general shape of your log curve. And it's a reflection about this line, y equals x. Okay, so if you were to fold the graph on the dotted line there, you will get the mirror image of your exponential as your log curve. Okay, so we say that it's an inverse, and we talk only about inverse functions for extension 1 students and above. Right, so we'll look at more about inverse functions when we get to it. Okay, so that's the features that you will be handy to know. Alright, let's look at some examples. Log base 2 of 32. Right, so I'm going to use my rule. So log base a of y is equal to x. Let's call it x here. So we're really finding that value for x. Okay, then a to the power of x equals y, using the identity that we've done at the start. Okay, so the base is vertically lined up, and then these two features are interchanged. So in other words, 2, so replace now the variable, x, which is what I'm working out, equals 32.
Oh, wow, that's cool.
Okay, so 2 to what power equals 32? So 2, 4, 8, 16, 32. So 5. 2 to 1 is 2.
Oh, wait, yeah.
Squared 4, 8, 16.
I thought I read that. It's 4 for some
Okay, so that means log base 2 of 32 is 6. Sorry, what about 16? You got me confused. Alright, so 2 log base 2 of 32 is equal to 5 because 2, this gives you the power, okay? This is the power as the answer for the log. So 2 to the power of 5 is equal to 32. Alright, so it's really a new way of thinking. Alright, log base 10 of 1,000. Alright, so we want to know the power for the base 10. So remember, this is also a base. This A is the base to a power, base number to a power. So we need to know what are the base to what power equals 1,000. Okay, so 10 to what power equals 1,000?
3.
Okay, so that's the answer we're looking for. So let's write down the rule. So a to the x is equal to y. This will help you to remember this because I often forget this myself. Alright, this is one I had to actually sit down and work through the question. So, drop it vertically, the base, and interchange the other two variables. Okay, so I've picked this up while doing a bit of research, and now I actually remember it pretty good. Okay, alright, so 10 to the power of x is equal to 1,000. So, in other words, 10 to the x equals 10 cubed. X is 3. Morning.
Morning.
You want to tell these guys a bit of history about logarithms? In your personal experiences?
My personal experience of logarithms, what would you like to know? The history of logs, where they evolved from?
Might as well.
I can't remember. On the spot there.
That helps.
Can't remember. That works, so.
Alright.
Can you remember Mr. Lee?
No. I was too young.
I know for some reason students struggle with them, and I think the reason why they struggle with them is they don't understand the basics of logs. If you work hard on understanding the basics of logs, then you'll be right. There's a couple of people in here who owe me some work before the end of this term. This term's rapidly running out.
Sure is.
Or owe Mr. Lee some work, so